Today is day 5 of Unit 7. Today we started with the timed exponent quiz. So if you were absent, you're going to need to make that up. After we did that, we did a warm-up. So take a moment, pause the video, try the warm-up, and then check your answers. So I'm going to take a moment to try these. So the square root of 27 I know is 3 root 3. I'm just going to deal with all the ones that are even, that come out evenly first. So 4 divided by 2 is 2, so that's x squared. 3 we'll deal with in a minute. 8 divided by 2 is 4. And 6 divided by 2 is 3. Okay, so those are all the ones that are the whole numbers. And it was an even root, and the only one that came out odd was the b. So that needs an absolute value, the others don't. The next to the y's and the a's, even if they end up being odd, we won't put absolute value because 3 halves and 5 halves are not whole numbers. So I'm going to rewrite the square root of y to the third as the square root of y squared times y, which equals y times the square root of y. So let me put a y underneath there and let me put a y outside. Simplifying the b or the a's, square root of a to the 5th is the square root of a to the 4th times a, which is a squared times the square root of a. Looks like I'm out of space there. So let's start to write that. So I have a 3. I have an x squared y z to the 4th absolute value of b cubed. And looks like I forgot my a squared. So let me write that out again. So I have 3a squared x squared y z to the 4th absolute value of b cubed. Scratch that out. And then I have a square root, and I have a 3y x squared. Wait a second. No, the x squared's not underneath. Just 3y and a. So 3ay. Now, because I have so many things written here, let's just double check that and make sure we have it all correct. So 27 is 3 root 3. Got it. X to the 4th, the square root is x squared on the outside of the root. Square root of y cubed is y times the square root of y. That looks good. Square root of z to the 8th is z to the 4th. That looks good. Square root of a to the 5th is a squared times the square root of a. And I'll cross that off now. And the square root of b to the 6th is b to the 3rd, but I need the absolute value around it. Yep, that is correct. Okay, number 2, these are all problems. These are obviously easier ones, but these are all problems that are going to demonstrate the process we're going to talk about today, which is solving exponential equations. So I see an equal sign, and I see that the exponents are equal, which means that the bases are equal. So that means x is equal to 2. The second one is similar. I see an equal sign, which means both right and left side of the equation are equal. And in order for that to be true, the exponents have to be equal, which means 4 has to equal x. And that's because the bases are equal. So same idea here. The bases are equal, which means the exponents have to be equal. So I set the exponents equal, and I solve, giving me x is equal to -2. That is my solution. And that takes care of the warm-up. So in class, we did some more similar to that, but again, a little bit more difficult. So this first one, copy that in your notes. The process is similar, although I don't have the same base. So I can't just say x minus 1 equals x. I can't do that yet because the bases aren't the same. So what you want to do is you want to rewrite the 9. You want to rewrite that so that it has the same base as the 3. Well, they share a base of 3, so that's easy to do. So I'm going to copy the left side of the equation, and 9 is the same thing as 3 squared, and that's to the x power. And I'm able to do that because 3 squared is equivalent to 9. So I didn't change the problem, I just changed the way it looks. So 3 to the x minus 1 is equal to, and here we have something to a power. We know the rule says we multiply. So that's 3 to the 2x power. So now I can set the exponents equal and solve, which is going to give me -1 is equal to x. Remember, if you want to check that, you can substitute it into the original and you should get a true statement. So B is similar to A. However, I can't rewrite 27 to have a base of 81, and I can't rewrite 81 to have a base of 27. So this one, rather than doing that, you have to rewrite both sides of the equation. So what we need to do is figure out what base they share, 27 and 81. That's 3. So I'm going to rewrite 27 as 3 cubed and 81 as 3 to the 4th. So then I'm going to go ahead and multiply the exponents. So 9x is equal to 4x plus 16. And solve for x. So 5x is equal to 16, which means x is equal to 16/5. The last one is similar, but this time I'm noticing that 1/64. I'm going to ignore the 1 for a minute, and I'm just going to focus on 64 and 16. Well, 64 and 16 share actually 2 different bases. You could say they share base 2, or you could say they share base 4. Either would be correct. They don't share base 8 because I can't take 8 to a power to get 16, and they don't share base 16 because I can't take 16 to a power to get 64. So either 2 or 4 are my options. So I think I'll just do this one with base 4. I think that's what we chose in class. So I'm going to rewrite, first of all, the right-hand side is easier, so I'll start with that. So 4 squared to the x minus 2 power. And again, I'm pretending for a moment that 1's not there, so I'm just going to copy the 1, and I know that 4 cubed is 64, and that's the 2x power. So I don't have the bases the same yet. I have a 4 on the right, and I have a 1/4 on the left. So I need that to say 4. Well, 1/4 cubed is the same thing as 4 to the -3 power, and we learned that earlier in the week. So 1/4 cubed is the same thing as 4 to the -3. So I have 4 to the -3, and that's to the 2x. And now I have like bases. So 4 squared to the x minus 2. So now that I have like bases, now I can set the exponents equal. So I have -3 times 2x is equal to 2 times the quantity x minus 2. So I'm getting -6x is equal to 2x minus 4, which means -8x is equal to -4, which means x is equal to +1/2. Okay, so the key with that was just kind of ignoring the 1 for a moment and figuring out what base they share, and then rewriting it so that they have that same base. So on the left, that's going to involve a negative exponent because I have 1/4 cubed rather than just 4 cubed. But then once you do that, solving is easy from there. Had you decided to use the like base of 2, you would still end up with x equals 1/2 as your answer. It would just look a little different because we would be rewriting 16 and 64 with a base of 2. Okay, after we did that, we did some factoring problems, and I mentioned that factoring was unit 3, and at the time in unit 3, we didn't really do a whole lot where the exponents were larger than 2 or 3, but now that we're more experienced with exponents, now we're ready to tackle factoring with higher exponents. So if you recall, in unit 3 and all along all year, I've been saying that the first step of factoring is to pull out the greatest common factor. That is no different now. So that's the first thing we're going to do. So I'm looking at these as 2 different terms, and I'm comparing the x's, y's, and z's and determining the greatest common factor. So between x squared and x to the 5th, I know x squared is the GCF. Between y cubed and y squared, I know y squared. And between z and z to the 7th, I know z. So once I've pulled out that greatest common factor, there's a minus sign in between, and now I'm going to figure out what this term is and what this term is. So taking them one at a time, x squared times what gives me x squared? That's just a 1. Y squared times what gives me y cubed? That's a y. And z times what gives me z? That's just a 1. So the first term is just a y. Now we're moving to the second term. So x squared times what gives me x to the 5th? That's x cubed. Y squared times just a 1 is y squared. And z times what gives me z to the 7th? That's a z to the 6th. So it's at this point you need to check to see if it factors further. Well, I see two terms and a minus sign, which makes me think potentially difference of squares or difference of cubes. So then I check the exponents. This 3 and 6 is really making me think difference of cubes, but the y is not to an odd exponent or a multiple of 3. So I know that it's actually not difference of cubes and it's not difference of squares because I don't see a squared. So it does not factor further. That is my final answer. So then I told students in class to try B. So you might pause the video and try it. So I'm going to factor out the greatest common factor, which is 2x squared y. I'm left with 8x cubed plus 27y cubed. And I'm recognizing that that's sum of cubes. So I keep my GCF, binomial and trinomial. Cube root of 8x cubed is 2x. Plus sign, cubed root of 27y cubed is 3y. When I square the quantity 2x, I get 4x squared. Because this was a sum, that's a minus. 2x times 3y is 6xy. This sign's always a plus. And 3y, the quantity squared, is 9y squared. And that is my final answer. Last one. So this one's a little bit tricky. You need to really think about this one. We are going to start with greatest common factor. And after looking at it a little bit, hopefully you're realizing the greatest common factor is x to the n. So after I pull out the greatest common factor, I'm deciding what it needs to be multiplied by. So I have x to the n times something. Well, what you need to remember is when we have like bases, so I'm seeing if it's going to be x to some power. When we have like bases and we're multiplying, we add the exponents. And I know that that result, that product, when I add the exponents, because I'm multiplying the x's, I know that that's going to be n minus 3. So if I already have an n, and I want n minus 3 from adding, that tells me that this exponent has to be a negative 3. So I have x to the negative 3. Then there's a minus sign. X to the n times what is 64x to the n? I know that's 64. So I'm noticing a negative exponent, and we know we can't leave negative exponents. The negative exponent goes with just the x. So I'm just rewriting the x as 1 over x cubed, and then minus 64. Now I'm seeing two terms minus sign, and those terms are perfect cubes. So I'm realizing that's difference of cubes. So I have a binomial and a trinomial. The cube root of 1 over x cubed is 1 over x. The cubed root of 64 is 4. That's a minus sign. And then I'm taking 1 over x, and I'm squaring that quantity, which is going to give me 1 over x squared. Squaring 4 gives me 16. This is a plus sign. And lastly, I'm doing 4 times 1 over x. And if you want, you can put that 4 over 1. Multiplying straight across gives me 4 over x is my middle term. And now I can't factor that any further. That is my final answer. Your homework tonight is all of pages 12 and 13, and then just these select problems 4, 9, 16 through 19 on worksheet number 5. Now, take notice, please, that this worksheet number 5 is in Unit 3. We are currently in Unit 7. However, I want you to go back to Unit 3, Worksheet 5, and do those problems. Okay, so that's not a typo. That is intentional. We're going back to Unit 3, Worksheet number 5. So that's your assignment for tomorrow.